In this video, we're going to discuss ionic bonding based on two definitions. One is between metal and non-metal. Another is between cation and anion of monoatomic and polyatomic ions. Ionic bonding is formed when metal transfers electron to non-metal. By transferring the electrons, metal and non-metal will achieve the same electron configuration as noble gases, which are very stable. An example of metal is lithium, which has 3 electrons and has the electron configuration of 2.1. Fluorine is an example of non-metal and it has 9 electrons. Its electron configuration is 2.7. Lithium has 1 electron in its outermost shell and fluorine has 7. These electrons in the outermost shell are called valence electrons. Since it's easier to transfer 1 electron from lithium to fluorine than it is to transfer 7 electrons from fluorine to lithium, that's the reason why electrons are always transferred from metal to non-metal. After lithium transfer 1 electron to fluorine, lithium ion now has 2 electrons remaining. Its electron configuration looks exactly like helium, the noble gas in period 1. The charge on lithium ion is +1 because it transferred 1 electron. Fluorine accepted 1 electron to become F-. It now has 8 electrons in its outermost shell and has the same electron configuration as neon, which is 2.8. Now both ions of lithium and fluorine are stable like noble gas. Here's another way to show the transfer of electron from lithium to fluorine. We use the Lewis symbol for each element and show lithium transferring its 1 valence electron to fluorine. The name of the ionic compound formed is lithium fluoride. Notice that the name of metal remains the same. Lithium metal forms lithium ion. However, the name of the non-metal changes. From fluorine metal, it changes to fluoride ion. We rename it so that it ends with IDE. Lithium fluoride is a very simple ionic compound since it involves transfer of 1 electron from metal to non-metal. Let's explore a slightly more complicated example between aluminum and oxygen. The electrons in aluminum and oxygen are arranged this way. Notice aluminum has 3 electrons in its outermost shell, while oxygen has 6. 2 electrons is going to be transferred from aluminum to oxygen. Oxygen at this point has already reached octet. It already has the same electron configuration as a noble gas. Since there's still 1 more electron left in aluminum, let's draw in another oxygen and we transfer that electron. Now that oxygen that we just drew in is still missing 1 electron, so we're gonna have to draw in another aluminum and then we do the transfer. Now the second oxygen is already octet, but aluminum still has 2 extra electrons that it needs to give away. So we're gonna draw in 1 more oxygen and then we transfer the electrons. Now each of the aluminum has transferred 3 electrons to a total of 3 oxygens. That gives us Al3+ with 2.8 electron configuration. Since oxygen accepted 2 electrons each, they are now O2- with 2.8 electron configuration as well. Here's the other way to show the transfer of electrons from aluminum to oxygen using Lewis symbol. And the ionic compound that we form is called aluminum oxide with the formula Al2O3. LiF and A2O3 show the ionic bonding formed between metal and non-metal. A broader definition of ionic bonding involves the attraction between positive ion and negative ion. We call the positive ion cation. Here are some of the examples of cation. The negative ion, we call it anion. Notice that there are 2 types of ion present. The ion that has only 1 atom, we call it monoatomic ion. This type of ion is formed from metal and non-metal. We've already seen this previously. Whereas the ion that has multiple atoms, we call them polyatomic ion. Poly means many. So it's an ion that is formed from at least 2 atoms combined together. We have an example of monoatomic ions combined together to form ionic compound. This is the same as what we've seen between metal and non-metal. Here's another example of ionic bonding but now it's formed between a mixture of monoatomic and polyatomic ions. Magnesium ion combined with phosphate ion. Together, they form magnesium phosphate, Mg3PO4 2. Notice that we don't change the name of the polyatomic ion, we keep it as is. We start with phosphate ion, and when we name it as an ionic compound, phosphate remains as is. We don't have to change the name like we did for the monoatomic anion. We change its name so that it ends with IDE. Notice oxygen changed to oxide, IDE. With that, we're done talking about ionic bonding. Quick recap, we talked about how electron is transferred from metal to non-metal. We also broadened the definition of ionic bonding to include cation and anion, covering both monoatomic and polyatomic ions. I'll be releasing more videos in this ionic bonding series, so do keep an eye out for them. Here are 2 more videos that might interest you. Thanks for watching all the way till the end. If you find this video helpful, be sure to like and share it with someone. Don't forget to subscribe. Your support means a lot to me.